Hey guys, it's Jake here. I'm the owner and operator of a residential HVAC business based out of Johnson City, Tennessee. And I wanted to do a video. I'm down here in my basement again, real high budget production as you can tell. But I wanted to do a video on how you can actually test a diode out in the field using a 9-volt battery, your electrical meter, and a few alligator clips. This is what a diode looks like here. This has got a white stripe. This came out of a microwave oven, actually. It's a common failure point on microwaves. This would lead up to the magnetron. But if this diode goes bad, then the microwave won't heat. But you can also find diodes in constant torque and variable speed ECM motors, blower and condenser motors, if they have them. You can also find them in inverter boards. Basically, you put 4 diodes together and you make a 4-way rectifier or full bridge rectifier. And that's what cleans and smooths out DC voltage for inverters, along with, of course, the use of capacitors. But I wanted to just basically go over diodes, how they work, and then we're going to do a test here on my son's old table here. And I'll show you how you can test a diode in the field to see if it's actually functioning or not. Okay, so this is a diode here. It's got a white stripe or striped end or a white circle around one end and a black side. And basically, a diode allows current to flow in only one direction, okay? So imagine like a gate valve or a backflow preventer or something. You have current going this way. That diode will allow that current to pass. But then if current tries to come back this way, that valve or that backflow preventer closes and prevents current from coming back this way. So that's how a diode works. The white circle side, this side here, is the cathode side, and that's the side that would hook up to the negative power source. And then your black side is the anode side, and that would hook up to the positive side. Okay, so you have cathode, white side, anode side, the black side. Cathode side is your negative, and your positive is on the black side. So a diode can work as either a conductor or an insulator. It depends on how you wire them up, right? So the white circle side, or the cathode side, or the striped end of the diode, that hooks to your negative side. And then the black end, or the anode side, that would hook up to your positive side. And this would allow the diode to act as a conductor, and it would allow current to flow according to its forward bias, okay? But if you wanted the diode to act as an insulator, okay, you would just flip it around. And in this instance, your white circle or striped end, which is the cathode side, you would hook that to your positive. And then the black end or anode side, you would hook to the negative side. And at that point, this diode then acts as an insulator and current won't flow due to its reverse bias. So diodes are also, like I had mentioned, they're used in constant torque ECM and variable speed ECM motors. They rectify that voltage from AC to DC. As we know, those ECM motors are DC 3-phase, and that diode is used to rectify that voltage. So that's kind of how that works. I'm not going into specifics on that, but I just wanted to mention that's where you can expect to see diodes out in the field with HVAC on those motors, as well as in inverter boards. As I mentioned earlier, diodes can be used for inverters. I'm no electrical engineer. I went to school for construction engineering technology. But let's say you hooked up one side of a transformer to AC current, and then on the other side, you hooked up a single diode or a rectifier. You would then have a really, really rough pulsating DC current with only the positive side flowing. And that's what's considered a half-wave rectifier, okay? So basically come to that diode and then boom, stop. You're not going to be able to have a flow using this diode or rectifier on the other side. But if you hooked up 4 diodes, you'd make what's called a full bridge rectifier or a 4-way rectifier, and then you could control how the current can flow, because the diodes would then allow both the positive and the negative side to pass. The negative side, though, gets inverted, and becomes the positive side as well. This is again is how inverters work. And then so that further smooths out that really rough pulsating DC current using a full bridge rectifier or a four-way rectifier. And then what they do in inverter boards as well, they put capacitors on that same circuit, and that even further smooths out that DC current with the use of capacitors. Like I said, I'm no electrical engineer. There's probably plenty of people out there that got way more scientific things to say. But I just want you to kind of understand what these things can be used for and how they work. Let's go ahead and test this thing using my electrical meter set to DC volts. We're going to have a 9-volt battery, of course our diode, and I think probably 3 alligator clips should do it. Okay, so we're making my son's old table here. He cut this thing up with a pocket knife and all kinds of stuff, but we're going to use this as our table here, and we're going to set my meter to DC volts, and we're going to test this 9-volt battery so that we can get a reference for how many volts this thing has. Okay, so we're at 9.31 volts DC. Okay, so now what we're going to do is hook this diode up in series with this 9-volt battery and our electrical meter. Pretty sure we're going to need all 3 of these, 3 alligator clips, and we'll be able to test this diode. So if we're reading 9.3 volts on this battery, we should have a drop in voltage if the diode is working correctly. Normally about 3 volts or so on something like this. So if we got about 9.3 volts, expect maybe 6 volts, 6.3, 6.5, somewhere in there. We'll lose about 3 volts on this testing it. Now if I tested this and I did not see a voltage drop, then the diode is bad. Okay, so if you hook this up in series with the 9-volt battery in your meter and you test your battery first and it's reading 9.3, 9.6 volts, and it reads that when you hook this into it, that means your diode is bad and it is not functioning. Okay, but if we read a voltage drop, the diode tests good. Okay, let's go ahead and hook this thing up here. If you remember, the black side is our anode side, and it will hook to the positive side of the battery, and our striped end or circular end, you see that? That is our cathode side, and that will hook to the negative side of the battery. All right, let's go ahead and hook this thing up. All right, let's go ahead and get this thing hooked up. We're going to hook up to the positive side of this 9-volt battery. Try to do this one-handed without making too much movement here. So we're going to hook one of our gator clips up to the positive side of the 9-volt. Again, we're going to hook up the gator clip and we're going to go into the black side of the diode, which is also known as the anode side. Remember, that hooks to the positive if we want current to flow through it, right? So we're just going to do like this, boom. Then we're going to take this gator clip and we should just connect to the striped side or the circle side. That's also known as the cathode side. So that's going to be on the negative side. And what we're going to do is just hook this up to one leg of my meter here. All right. And then I'm going to take this gator clip and we're going to hook it to the negative side of the 9-volt battery there. Let's probably grab it like that. And then we'll hook this up to the other side of the electrical meter here. It's like my 9-volt just fell over. All right, let's see if we got a voltage drop here. And we do. We're at 6.04 volts DC. So that tells me that the diode is functioning properly and that we have a good diode here because we're getting a voltage drop through the diode. Again, if we didn't have a voltage drop through that diode, if my battery was 9.3 volts at the initial test in for reference, and I was reading 9.3 right now, then we'd know we'd had a bad diode, okay? So that's kind of how that works. Pretty easy. It's a nice little test you can do out in the field. If you wanted to test a diode, or if you have a microwave oven that's stopped functioning, you know, things like that, you can just grab a simple 9-volt battery, 3 gator clips, and an electrical meter, and you can test a diode out in the field to see if it's functioning properly. Voltage drop on the diode when you're reading it. On the meter you see a voltage drop, diode is functioning. If you don't see that voltage drop, diode is bad. Well, this is just a little short video, as my buddy Dave used to say before he passed away. A little sweet pea of a video. Maybe help somebody out in the field or out in trade school, or even a homeowner that has maybe a microwave that's not producing any heat. If that diode does go bad, your microwave's not going to produce any heat. So all you need is an electrical meter, 9-volt battery, a few gator clips. If you don't have the gator clips, you could just use some wire, wrap it around the thing if you had to. I mean, you don't have to be fancy out here. It's a real down and dirty way to test a diode to see if it's functioning. If you have a voltage drop when you do the test with this thing in series, then the diode is good. If you don't see a voltage drop, then of course the diode is bad. Always make sure to test the voltage on the battery first. Write it down if you need to, but you need that reference point first and then do your test. Voltage drop, diode is good. No voltage drop, diode is bad and needs replaced. Well, I appreciate you guys taking time out of your day to watch this little video. I got more to come with little training videos like this for newer guys out in the field, or even homeowners or something that are just interested in it. If you're an old seasoned tech, it's probably not going to help you, but I figured I'd do the video anyways. Just trying to put some videos out on the channel. And I just want to say thanks for watching. I really appreciate it. If you haven't already, hit the like button, subscribe to the channel. Maybe leave a comment. Let me know what you think about the video. Stay safe out there, guys. Get home safe to your families. Most important thing you can do every day when you work in the trades, just get home safe to your family. You guys take care. Stay safe, and I'll talk to you later.